à, à, à. Yeah, very good evening. Good afternoon. Okay, so let's start. Yeah, good evening. I am almost well, but little bit still cold is there. Still it is there. I feel weather is changing right now. Okay, so today let's start with just wait, student, wait. What is happening here? Just wait. Wait here. Okay. So let's say today I want to work with machine learning. Let's say I want to work with the machine learning. What is the machine learning, first of all? Just wait, Sandra, wait. Okay. Still, this weekend classes will go on. Yeah, today I'm a little bit better. Yeah, as compared. Wait here. Still, live classes I will conduct. Okay. Number of live classes are remained here till now. Okay. And same time will go. Okay, Sandra. Okay. So let's move ahead with the machine learning now. Still, a lot of classes are remained actually, and the same timing and the same weekend classes I will be conducting as it is. There's no change here. Yeah. So you can think accordingly your schedule or other things, other aspects which you are worried about. Okay. So here, let's go ahead with the machine learning now. This was a far-awaiting topic, machine learning. So let's understand how the machine learning actually works. Before starting with the machine learning work, let's understand, first of all, what is learning? What is general learning I'm talking about? How does the learning occurs? If I say just what we can do, we can simulate the teacher child learning. It means we can simulate the entire machine learning with the way the child is learning under hood of the teacher. See, there's a small child. First time the child is going to the school, okay, or the preparatory classes, means the very first step into the school life. So the child is not aware that what to do. The teacher is there into the any of the school, preparatory school, smaller school, you can say, or higher school. The child at the first time interaction, when the child has the first time interaction with the teacher, the child does not know what this teacher is asking or what she is or he is saying to the child. The same happens with number of days. The same scenario will goes with the number of days. The child is not able to understand whatever teacher instructions are coming. But after continuous days, suppose I say 10 days, 15 days, 20, 30 days, whatever that time it will take, the child will slowly start learning about A, B, C. So the child is able to understand that what this teacher is speaking about. She is speaking about something about A, B, C, she is telling. So the child starts following the teacher commands such as A, B, C. She is so showing those characters, explaining those characters. Later on, the child will understand that A is for the apple, B is for the bat, C is for the cat, and goes on. So the point is here, the child is here. Child is able to learn something in the class. The child is able to learn something in the class. That madam is saying A, B, C, D, or ma'am is conveying about some 1, 2, 3, and some words the child will start at least understanding that apple, bat, rat, cat, she's explaining. But this process or the learning of the characters or the learning of the integer or the learning of the string values, means cat, rat, mat, bat, the child is learning. That comes with the time. And that also take the continuous learning. Teacher is continuously explaining. She is making regular practice to the child. And slowly, you can say 1 month, 2 month, 3 month, 4 month, the child is able to grasp the word. Child is able to grasp that madam is saying something. And even after every day, like the child is moving at home and next day the child is coming. So the child starts remembering that she has taught about 1, 2, 3 or apple, bat, rat, cat, mat. Okay. The point is that the child is learning with the time. The child is learning with the time. Okay. He or she is able to understand the concept with the time, with smaller to higher. And it is taking like days into weeks and months also. Okay. And once the child is able to learn these words as well, after that, the child is able to learn or understand the lines, and slowly the child is able to understand the paragraphs and the essays. What is the scenario? We are simulating entire machine learning with a teacher-child learning here. That initially the child is not able to understand what the teacher is teaching whenever the child is moving first time into the school. But later on, the child starts learning the concept when the teacher is repeating the same concept over and over time to the child. The child starts learning with the time. So initially the child is completely zero. The child does not understand, but slowly after continuous repetition, continuous learning, the child is able to grasp the things here that, okay, that the teacher is expressing something or she is teaching something. So this process will be on. Okay, so let's say the child is able to learn certain words or lines or paragraph, let's say. It's okay. So what I'll do here, I'm giving you new words now. It means that when the child is learning, suppose here I'm saying, child is learning question, answer. Suppose here, I had given one chapter and I had asked the child or student to learn this chapter. So inside the chapter, let's assume, suppose there are 7-8 questions are there, and I had mentioned the answer as well. Okay, means suppose I made certain question and correspondingly answer to the child, and I'm asking child just to learn these things. Whatever smaller learning, even you can just say cat, rat, mat. So the child is learning those things. So the point is here, I created a book where I had written a question and answer. So the child is learning actually. This is the question, this is the answer, this is the second question, this is the answer, this is the third question, this is the answer, and goes on. So what will happen in this case, this phase where the child is into the learning stage, that stage I will call technically as the training stage. I am saying this one is a training stage. Okay. So here the child is completely learning. Learning stage is a training stage. I am giving a technical name to this stage. Okay. Now, like child says, okay, ma'am, I had learned everything. All 8 question and answer you had gave. It's okay. Now I told, okay, as you had learned, now what I'll do, I'm going to take your test. Let me take your test. So, okay. So what I did, I gave some questions for the test. Let's say I gave question number 3, question number 6, question number 7. I created a test and I had asked the child to give the test. So this phase where I am asking the child to give the test, technically this is a testing phase, training phase and the testing phase. Then I am asking, this is the test here. So you start giving your answer. Start giving the answer for the question number 3, question number 6, and question number 7. So style will start thinking on its own based on whatever the child has learned. So here he will start giving its own answer. So here some of the answer child will start giving on its own based on the learning or training. Now here I'm having another thing also. I'm having, let's say, original answers. I'm having original answers also. So these are, I'm having original answers. The point is that during the training phase, the child has learned 8 question and answer. And later on, I asked, since like you had learned everything, so let me take your test, which is coming into the testing phase. And there I had gave certain questions to the child during the testing phase, and the child start giving answers. When the child start giving answers, then here I will start taking original answers also. So I'm having the child-driven answers and the original answers, which are here. Now what I'll do, let me make the comparison here. So I will be taking child answer, whatever answer the children has given, and original answer. So let's say, suppose here, question number 3, question number 6, question number 7. So some of the answer the children has given, okay, and some of the answer means some of the answer the children has given correctly. So if the children has given answers correctly, what I'll do, I'm just giving it a green signal. Green means both of the answers are matching. Both of the answers are matching here. Got the point here? Both of the answers are matching here. So it means the answer of question number 3. Suppose this is a question number 3 here. So here, question number 3 answer is same, just like original answer. Then question number 6. The answer is a little bit different here. So I will say there is a change into the answer. So this answer number 6 is not matching to the original answer. So this is a different answer. So original answer is different. Student has given certain another answers which is not matching. In 7 number, the child answer and the actual answers both are matching. The point is, we are matching out the child-driven answers as well as the original answers. And in case we are finding it out if all the child-driven answers and the original answers are matching, it's good because all the answers are same and the child has learned well. But if there is unmatched in the child answers and the original answers, okay, so we do consider it as an error. So error in simple way also you can think if you are into college or you are into school. So the same thing happens that if your answers are matching with the original answers, it means you did well. And if your actual answers are not matching with the original answers, like the answers which you had given into during the test, and they are not matching with the original answers, of course, that comes to the error. If one is having less error, so it means your work is quite good. You achieved higher marks because errors are less. And if all of your answers are matching with the original answers, that is well done, means all the answers are same as per the original answers. So you secured very good marks, okay? But errors can also happen if they are unmatched. However, so it means your matchings are not there. So actually, this one is a child learning I'm taking. So 2 phases I told, like training phase and testing phase. Got the point? Training phase and the testing phase here. So basically now let's simulate, like here I'm simulating child learning with the machine learning. So the point is here that when I talk about, machine learning, let's come to the machine learning here. What happens during the machine learning also? The machine learning also works just like similar here also. Same thing. Like the way the child has learned, it took its time, and initially it does not know what the teacher is saying. The same happens into the machine learning also. In machine learning, we are having a lot of algorithm. Okay. And with the machine learning, with the help of a lot of algorithm, the machine also starts learning with the data. We provide a huge data to the machine. So what happens? Initially, the machine will not learn anything. Okay, because machine does not understand what is going on. We are providing some data, the machine is not able to learn. But when we provide the continuous data, means here we are continuously repeating the data, we are providing more and more data to learn the machine. Machine will start learning after a certain point. And it will keep on going learning. So with its experiential learning, with its self-experience of learning the data, machine will start learning the data and start responding to the questions as well. So that comes with the machine learning. So here, just wait, here, when we talk about the machine learning, during the machine learning also, we do have same phases. We do have same phases, just like I'm giving a machine question and answer. Okay. Such as here I'm giving a question and answer. So a lot of questions I'm sending to the machine. A lot of questions I'm sending to the machine. And I'm giving a question answer, question answers, question answers. So suppose here you say like 15 questions, 15 questions I'm giving, 15 question and answer I'm giving to the machine to learn. Okay, so initially machine will not learn, but after continuous repetition for the same task, at one point the machine will start learning. So initially it will learn only few things, but later on, after continuous repetition of the data, we are giving it, we are asking it to learn. So machine will start learning the data after a certain time, and it will start responding also. Now, if I say question and answers, machine, you start learning this question and answer, start grasping it. So it will start grasping. And when it is grasping, so I will call this stage as the training stage. So in machine learning also, we are having the training stage. Now let's see, machine is ready. Machine has learned all the 15 answers, question answers. Now I say, okay, machine, let me take your test. So I'm preparing a testing phase now, testing phase. So here I gave certain tests, such like I provide a question number 3, question number 5, question number 9. These 3 questions I'm giving to the machine during the testing phase. The machine will start giving its answer. Machine will start giving its answer. So machine answer, see here, I'm writing here machine answers. Machine will start responding some answers. Also, okay, machine answers. I'm also having original answers. Original answers mean I'm having these answers, like what is the answer of 3, what is the answer of 5 number, and what is the answer of 9 number. So these original answers also I am having. Now, during the testing phase, whatever answers are driven by the machine, what I'll do, I will take those data here and start looking here the machine given answer, machine answers, and the correspondingly original answers. This one. So then I will just check it out how many are right or wrong. So here now, let me take a very simple example here. Suppose here I say, these are the question. These are the question number 3, question number 5, question number 9. Let's say I'm giving you very simple things only. Suppose I'm asking a child, what is 5 plus 5? Though, you know, from the machine, we are not asking that what is a 5 plus 5, but here I'm creating a scenario just to understand. Here, Just wait. Here, I'm asking the machine, what is 5 plus 5? You have to give me answer because it is beginning of the child. I'm asking 2 plus 2. I'm asking 7 plus 7. 7 plus 2. It's okay. 3 questions I gave, okay, based on to your understanding. I'm saying, based whatever you had learned during the question answers. Suppose some mathematical, small mathematics exercises I had asked the children to learn and they had learned it. They did it. Now I gave 5 plus 5. Okay, tell me what is this? 2 plus 2, 7 plus 2, just to give me start answering, whatever you had learned. So here, now you think it's suppose here, machine is giving different answer. Machine is giving here that 5 plus 5 is 10. It's okay. Original answer is also 10. 2 plus 2 is 4. See, we know it. No? But when the child, smaller child is there, that does not know. So by chance, he mistaked. He said this is 3. You know this is 4. But children, small children, initially he or she has started, they don't know. Okay, but the original answer is 4. It's okay. It does not matter. Now here, 7 plus 2. You know, age 9. 9 is there, the original answer. But child has given, let's say, child has given 15. It's okay. Let it be whatever the child is thinking, because the child is child. Okay. So here, I took machine answers. So machine answers is saying 10, 3, and 15. And the original answers are 10, 4, and 9. So the difference are there. Machine-driven answers and the original answers are having the differences. Okay, so here we can find out the errors. Okay, so error is basically how much is the difference here. So you can say here, just making the sum of like here, this one 10 minus 10 is what is deducting the difference here. Like here 10 minus 10 plus 3 minus 4 plus 15 minus 5 minus 9. One is getting the differences divided by 3. So that one is getting the, if you are calculating it here, you are getting 0 plus 3 minus 4 minus 1 here, 15 minus 9. So you are getting the mean value. The calculated mean value is the error, basically error. So if this error is high, so it means your answers which student has given is less correct. And if your errors are down, so it is good. The child has learned more during the training. Suppose here you say, child has given all the correct answer, 10, 4, and 9, let's say. So 10, 4, and 9, let's say. So it means there is no error. All the answers are correct. So there is no error. Okay. Okay. So the point is here that here we are saying that here, if all the child-driven answers are same into the machine answers and the original answers, both are same, it is well and good. There is no error. The child has given all the answers correct. So it means during the training phase, the child has learned well. So here I'll say, during the training phase, the machine has learned well. And here, if the machine is not giving exact answers, so here it means the machine is machine-driven answers or the original answers are having certain errors. They are having certain errors. Okay, they are having certain errors. So the point is that here machine-driven answers are showing either some errors or no errors. So the point is here, when we talk about the machine learning, you should remember during the machine learning here, we are having these technicalities, these technical words that I'm having a data variable you can take with a question and answers always. Question and answers. And here we are having certain questions. in machine learning and answers are there, means any question and answers are there. So when the machine is learning the question and answer, so we do call it a training stage. And later on, once the machine has learned the data, then we start taking the test. So that one is the testing phase here. Okay, that one is the testing phase here. Now, here I will be writing the questions. So I will be writing certain questions for the testing, and here the machine start giving answers. So machine answers. So here I'm having the machine driven answers, and I'm also having the original answers. Then we need to check that whether the machine answers are similar to the original answers. Well, they are similar to the original answers. If there are certain flaws and both are not matching, it means errors are existing. Errors are existing, and that can happen here. That can happen here. Okay. Okay. So that is happening actually. Just wait here. Okay. So remember, in machine learning, training and testing is there. Training, testing is there. Okay. Now, the data which I am having, what I will do, I will divide this data into 70% and 30%. Student, it means the data which I am sending to the machine to learn. Okay. So here, %. Why I'm doing this 70 or 30%? You know what is happening here? Huh? Actually, suppose I'm taking a data. Any data here I'm taking. Any data which is having two variables, two columns I'm having. Date, there suppose you consider 100 rows I'm having, just to consider. So in machine learning, if 100 rows are there, na, so 70-30% division I will do for the training and testing. It means that 70% of the rows will be going for the training to learn the data, and 30% of the rows will be going for the testing of data. Or what I can do, one more thing I can do, I can take, instead of 70-30, I can take 80% to the training and 20% to the testing. Any of them I can take. 70 or 80, 70% training, 30% testing, or 80% training or 20% testing. Means any of them I can choose it just to divide the data. Got the point? So training, testing, 70%, 30% split, or 80% or 20% split of the data, and checking out the answers, differences between the machine-driven answers and the original answers. Okay. So this is there. Just wait here. So just wait here. Suppose. Okay. So in this way, some few technical terms I gave to you for the machine learning, which I'm making a simulation here right now with the child learning here. Now you see, suppose when I'm talking about the machine learning, okay, just wait. Okay, just wait. When I'm talking about the machine learning, so here, when I'm saying that when I'm giving a questions for the testing phase, and here I'm matching out the questions with machine answers, or original answers. So like question number 1, question number 2, question number 3, and then correspondingly machine answers and original answers I'm having. So when I'm checking out the errors, error one can find out mean absolute error here. So here one can find out the sum of differences of the actual answers, this one, the machine answers, and the original answers. Machine answers and the original answers, so that differences I'm having, okay, divided by n. So right now here 3 is there, so divided by 3. So that I can find out as an error. So this errors, when I'm taking directly, I can call it a mean absolute error. What is the mean absolute error going on? Or what I can do, if I'm writing it here, it as the square, I'm finding it out the square of the difference between the machine answers and the actual answers divided by n. So I can call it a mean squared error. So basically, your mean squared error is sum of x minus x bar, means machine answers and original answers, making the square of it, divided by n. So this one is a mean square error. So if this error is high, so your machine answers are correctly depicted. And if these errors are down, that is good. So machine is giving right answers. Okay, so in this way, we do consider the machine learning errors as well. Now, just wait here. Now let's go just to understand machine learning. Machine learning is a technique where the machine is learning with the data continuously, and it will improve its learning based on to its experience. So machine learning is divided into 2 categories. Okay, supervised learning and unsupervised learning. Supervised learning and unsupervised learning. Now, what is a supervised learning? Basically, supervised learning is a kind of learning where we need to give every time supervision. So like here, child is there, child is learning under the supervision of a teacher. Child is there. Child is learning under the supervision of a teacher. So in case of supervised learning, every time teacher is there. So how can I simulate it with machine learning? Okay, in a classroom, child is supervised by the teacher. But in supervised learning, now how can I make it simulated with the machine learning? That if you remember during statistics, I had told you there are dependent and independent variable. So here I can say that in machine learning, in case of supervised learning, there is an input variable as an X and there is an output variable also. So in supervised learning, there is a output or label or target column is always present. So it means Y is always present. It means we are having a variables with input, but output label or target variable or response variable, you can call it. That is 100%. That should be 100% there. Okay. The target variable must be 100%. So basically input and output should be there. 100%. Okay. So in supervised learning, you must remember input variable and output variable. And output variable must. So it means input variable is present in supervision of output variable. And you can consider this input variable as the question and output variable you can consider as the answer. So answer or output or label or target must in case of supervised learning. Okay. Okay, fine. This is the supervised learning. Now, if I say like, what about the unsupervised learning? So in case of unsupervised learning, I am having only X data. It means you can just consider as a class without a teacher. Only students are there. Only students are there. A class without a teacher. Only students are there. There's no teacher here. There's no teacher here. Okay. So that one is an unsupervised learning. There's no label. Only X is there. Now, when we talk about this supervised learning, there are further two categories of the supervised learning are there. Regression and classification. Regression and classification. Regression is being used whenever my Y output, Y is having continuous output, suppose 7.1, 8.3, 6.2, 8.4. Decimal values outputs are there in Y, in label output or target in case of regression. Now, there are further categories of the regression. The further category of the regression is linear regression. And the other one is logistic regression. Now let's understand what is the linear regression now. Okay, what is the linear regression now? So we do consider the linear regression in the case where I want to predict continuous outputs only. I need to predict house price, electricity bill, interest rates, temperature, doctor fees, salary. So we do use regression, linear regression, where the prediction comes to continuous outputs, decimal values outputs. So here, remember that, just wait. When I'm talking about the machine learning, wait here. When I'm talking about the machine learning here, I need to consider here machine learning. Machine learning is divided into two categories: supervised learning. Supervised learning and unsupervised learning. Supervised learning and unsupervised learning. In case of supervised learning, Y label should be must there. The presence of the Y label should be must. When we talk about the supervised learning, that is again divided into two: regression and classification. Now, regression also divides into two: linear regression and logistic regression. Linear regression we do consider in a place where I need to predict Y into the form of continuous output. Decimal values should be there. And I'm using this regression, linear regression, for the purpose of predicting electricity bill, house price, temperature, doctor fees, student fees, salary, or any other continuous data, So there the regression comes into the way. Okay. And here during the supervised learning, Y is must. Y means your output, your label, your target is must. So it means we are having input and output. So in case of supervised learning, there is 100% output variable is there. Input is there, but 100% output is there. In case of unsupervised learning, only input is there. Only X is there, only input is there. There is no Y. So just wait. Let's see into the depth now. Let's see into the depth for machine learning here, linear regression. Okay, so just wait. Now here, let's understand the depth of it, how it works. Basically, see, you think, suppose, let's take here, suppose I'm taking a data set. I'm just making a data set. Like I'm having X data set. I'm having Y. So X is the input and Y is the output, label, target. Okay, that is there. So here, let's consider I'm having number of hours for study. Numbers of hours for study as a number of hours for study as an input variable. And here I'm having the grade or marks. Let's say what is the grade achieved and what is the marks. In this way, we can understand. Okay. Now here now, I'm making this data. Okay, let me make this data here. Wait. So X is a independent variable. X is an independent variable and this Y is a dependent variable. Okay. Now here I'm making some data. Let's say, suppose one is studying for 6 hours. So the grade is 1. One is studying for 10 hours. So the grade is 2. One is studying for, student is studying for, let's say 15 hours, the grade is 3. If the student is reading for 22 hours, the grade is 4. The student is working for 26 hours, studying for 26 hours, the grade is 5. So, okay. So when I'm making the number of hours of study and the corresponding grades, so here I can term it, this one as the input and this one is the output. That if the students study for these number of hours, these are the grade. I will call it as training phase. Training phase here. Okay. Once the training phase is there, then here we can have the testing phase. We can have the testing phase. So here, here I'm giving a testing phase and I'm asking, suppose one student is studying for 8 number of hours. Then what will be the grade or marks achieved by the student? Or one student is studying for 18 number of hours. So what would be the grade or marks? Or if any student is studying 30 number of hours, so what would be the marks or grade? So the point is here, one is considering that if during the training, these are the different number of hours the student has studied. So corresponding grades are these one. Now this is a testing phase. If these number of hours the student is studying, start giving the answer that what grade would be achieved. So this answer, whatever answers this particular machine learning is going to give us, then these are the machine answers. MA means machine answers. And here I am having the original answers also. Whatever is the original answer. Whatever is the original answer. So those also I'm having. Once we are considering it. Okay, so second thing on, once we are making the entire data for the training and testing, I'm sending it, I need to split it. I need to split it into the training and testing, such as 70% of the data I will be taking it for the training, 30% of the data I will be settling down for the testing. Or I can take another way. I can say 80% of the data will go for the training, 20% of the data will go for the testing. we are having a lot of libraries for it to break the data into two, 70, 80, 70, 30 or 80, 20, we can do that. Okay, now let's come to the machine-driven answers and the original answers. So what I'll do here, I'm just making the assumptions here. Let's say like with 8 number of hours, if 6 is 1, it is 10. With 10 number of hour, 2 is there. So with the 8 number of hours, 1.5 grade is there. Or with 18 number of hours, let's say 4 is the grade. Or with 30 number of hours, 6 is the grade. These are the machine is giving answer. Machine is giving answer here. And the original answers are, okay, let me say original answers are the same. Let's assume both are same here. No? So there is no error here. No? Because all the answers like 1.5 minus 1.5 plus 4 machine answers and 4 actual answers, or 6 machine answers and the actual answers, this one. So divided by 3 here, 1, 2, 3, 3 cases are there. So one can make sum and we can give, once we are considering it here, so once we are calculating, it is completely 0 now. There is no error, 0 error here is there. Nothing is there. So errors are 0 in this case if it happens. So I'll say errors are 0. So it means everything is going fine. Our machine answers are correct. Okay. And if it is having certain difference, suppose here it is in 3.5, here it is in 5. So it is 3.5, here it is 5. So some errors are there. So once it is calculating, some errors will be there. So in this way, your machine is working. Got the point here? Now, actually, let's understand how these changes are coming. Some changes are coming here. Here, 1, 2, 3, 4, some changes are coming. So first of all, let's understand that how the equations are working. So basically, we are having equations here for the linear regression. Suppose I'm taking a linear regression here. I'm taking this. So for the linear regression, there is a particular equation which is working. Y is equal to A plus B x plus E. Okay, y is equal to A plus bx plus E. So here, now what is y? Y is dependent variable. Dependent variable. A is intercept. B is slope. X is independent variable. Independent variable. And E is errors. So basically, this is the equations working here. Okay, so in linear regression, y is equal to a plus bx plus error plus E. You can call it in this way, your things are working. Now what I'll do, I'm taking a variables, 2 variables here. Okay, let's consider the 2 variables. Just wait here. So here I'm saying the linear regression equation is y is equal to a plus b x plus E is the error, where y is the dependent variable, A is intercept, B is slope or coefficient value, X is independent variable, and E is the error term. So now I'm going to take, suppose, I'm going to take here, let's say this. Here I'm having X and Y, 2 variables I'm having. Y is target variable or dependent variable. Y is dependent variable, target variable or label or output or label it is. X is independent variable or input. Okay. So here, in input variable, suppose here I'm saying number of hours study, that how many numbers of hours study is there, and correspondingly grade is there, grade or marks you can assume. So the point is there how many number of hours study one student has provided and what are the grades. So now let me take this data one by one and let me map this data. So here I'll say this Y now, I'll say this target or grade. Grade is basically, let's say, grade is the target, grade is the output or label. So here I'll say one is to calculate the grade or the marks, which is a dependent variable. And to calculate the grade or the marks, it is totally dependent on this equation. So A is intercept, B is coefficient or slope, and X is independent. So this number of hours for the study is here. Number of the hours of the studies are here, independent here. Okay. It is there. So dependent variable, independent variable. So basically, to calculate the grade is dependent on this entire equation. Whatever the number of hours are there, correspondingly grades are there. Okay. Now, what happens? Suppose here I'm saying, okay, let's say suppose 6 number of hours, 1 is the grade. 10 number of hours, 2 is the grade. 15 number of hours, 3 is the grade. 20 number of hours, 4 is the grade. Let's assume. So here, what happens? I'll explain what are these here, A and B, what are these in detail. Wait. So suppose here, currently I'll take one thing. Suppose here, Y is saying, Y is what? Let's say 1 is grade. 1 is the grade when number of study hour, which is independent, because it depends on the student how many numbers of hours the student wants to study. So 6 number of hours. So this X will become 6. That if the student has studied 6 number of hours, then the grade or marks is 1. Means grade I am talking about. This is not a marks, it is a grade. So first grade the student is achieving. This is the first grade marks the student is achieving. With the 6 number of hours, the first grade marks the student is achieving. And when I'm going towards the 2, 3, 4, means these are the higher grade. Let's consider it as the higher grade side. So when the student is taking, suppose here, 10, student is giving 10 number of hours. So the student grade is proceeded or moved ahead with 2. 2 means I say it is a higher number of grade. When this student starts studying for 15 number of hours. So the change is coming for 3. So actually how it is happening, how the change is coming with increased number of independent variable, with increased number of hours, the study hours the student is saying, with increased number of study hours, when the student is giving the increased number of the study hours is there. So here, how these changes are coming, how these grades are increasing, how the dependent variable values are varying when input variable values are varying. Okay, that is happening. So here, this change is coming due to this coefficient or slope value. The slope value is added into the y here. The slope value is added into the y here. Okay, so if I say here, suppose the slope value, I'll tell you that how the slope value or coefficient value is also calculated. Okay. Actually, what happens whenever, see, I'll tell you this coefficient and slope entire formulas, how they are working. But currently you need to consider this coefficient or slope value is getting changed actually. Okay. And intercept currently, we can say it, let's say 0.1. I'll also tell how this is calculated, but you need to wait for that. Suppose here I say 0.1 and here this coefficient value, this slope value or coefficient value will be changed whenever this slope value coefficient value will be added into the y whenever there is plus 1 unit change is coming into the independent variable. It means that whenever suppose this number of study hours is increased by 1. That is increased by 1. So it means unit hours are changing. So corresponding coefficient calculated value will be adding inside this dependent variable. Whenever my independent variable is changing by unit or 1, the corresponding calculated coefficient value will be added to the grade, will be added to the dependent variable to give the final shape for the dependent variable. Okay, so here now we'll be understanding it in detail that how the changes is coming. Okay, and then correspondingly error is there. So the point is that the total game is for this a plus bx. A plus bx is there. Okay, so let me tell you how this is working actually. Okay, so this coefficient value, suppose here I say, let's say 1.0. 1.0 is the calculated coefficient value. Again, some formulas are used. The 1.0 is the calculated coefficient value with entire data sets. Now, whenever plus 1 is happening, so this will be added into the y, prediction of y. And the y value will be changed. Let me take one example here. Just wait. Let me draw here. Wait. Just wait. Wait here. Okay. Suppose. Just wait here. Just wait. Student need to wait actually here. Suppose I'm saying number of hours or Let me make it wait, please. Wait here. Okay, just wait. We can consider one more thing here before making it. When we are talking about, just wait. When we are talking about y is equal to, like right now I have told you the equation. Y is equal to a plus bx. First of all, you should know this is a straight line equation. Straight line equation, which you have studied during your middle classes. Maybe like 9th or 10th or 8th, 9th, 10th classes means, okay. So these are the straight line equations. So what it says that if I'm having data points, let's say data points I'm having. So the straight line says that it will try to make a line where maximum data points exist on that line. Okay, suppose initially the straight line equation will try to make multiple lines where the maximum data point could be filled out. Suppose here it is trying this way. So this yellow line it is not able to put any of the data point. It is not able to cross any of the data points. Let's see. This yellow line is only touching one data point. So what is happening? See, can you see here this point, this point? These are the intercept point from where the straight line equation is trying to make a kind of line where the maximum data points could be settled onto that line. So here's suppose let me make here 1 or 2 points. Okay, so fine. So student, these one, which I'm changing here, these are basically intercept. Intercept is that point from where the line is drawn and the maximum data points could be settled on those lines. Suppose here I'm saying, let's say. So only 3 points are existing. So the straight line will try to change this intercept again and again, and it will be situating at that intercept where the maximum number of data points could be settled again. Okay, so suppose one of the line I can take in a way where I can take in this way. Suppose here, let me take out this line in this way. So I will say, this point, this point is the intercept where maximum data points are existing on the blue line. Like 1, 2, 3, 4. 4 number of data points are existing on this blue line. So here I'll say this is a straight line equation where maximum number of the data points are existing onto the straight line. Okay. So this is intercept. So this intercept is A. So intercept is that point. This is the intercept. So intercept is that point from where the straight line equation is created, and that straight line equation will be settled down on maximum number of data points. Maximum number of data points. all the column and the rows could be displayed with the data points only. Please wait for that. Please wait for that. Okay. So these are the data points. Data points means these data points are coming from any data set. So here we are just making that one. So here I'm making you understand that what is the intercept. Intercept is that line from where the maximum number of the data points could be settled, and that would be considered as the straight line equation. So y is equal to a plus bx is a straight line equation where maximum number of data points could be settled. Okay, this is the equation. Okay, so this one is the intercept. Now what happens? So this is a case of intercept. So the same case here I'm considering here with the same line equation here, a plus bx. And here, now, so okay, this one is intercept now. So what I'll do here, just wait here, wait, let me take something. So intercept is clear. Now what I do, just wait. So here, let me write here, suppose if number of hours, I'm taking this one, number of hours and grade or marks here I'm taking. 1, 2. Okay, let me start with here. Suppose 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. Okay. So here, suppose here I'm just making some points. Goes on. Suppose here I'm taking a line here. Let's say from here my straight line is going. Suppose I'm having a lot of data points. And from here, let's say this 1.5 you can consider. This is the intercept. So this 1.5 is the A point here. This one is the A point. So I'll say, like here, let's consider for the time being. I'll say like A is the point from where the straight line equation is considered. Now here now, what happens like when we say that this is the independent variable, which one? This one. This is the independent variable, which is a number of hours. So it depends on the student how many numbers of hours the student is studying. Now here, if I'm saying if plus 1 number of hours, whenever plus 1 change is coming into the number of hours, independent variable, so correspondingly coefficient value of the slope value will be added into the y. Y is dependent variable, it is grade. So here, let's consider this number of hours. So number of hours is, let's say it is 1. So currently, okay, let's consider if 1 is the number of hours, if student is studying as 1 number of hours, let's say. So here, let's say 2 is the grade here. 2 is the grade. Now what I'm doing here, I'm adding plus 1. It means 1 more number of hours the student is studying. So here, what will be the impact onto the grade? So you can say here, see this line. If the student is studying one more number of hours. So +1 is changing into the X. So correspondingly, Y will be increased by 0.5. 0.5. So Y grade will be 2.5. So it means if +1 increase is there in input, so 0.5 slow 0.5 coefficient value. This is a 0.5 coefficient value, and this is a slope, this is a slope basically. So 0.5 coefficient value, this will be added into the grade. So if the grade is 1.5, so this coefficient value will be added into grade. So 1.5, 0.5, so that becomes 2. So it means here, here what? It is 2. So 0.5 is added, so the grade will be 2.5. The grade will be 2.5 if 0.5 coefficient value will be added into the Y when +1 increase is there into the number of hours. Then again, +1 is increased. One more number of hours increased here. So here, when one more number of, let's consider 3 is here. So one more number of hour is increased. So what will happen? This change which is coming here, that is a 0.5 change here. So this change will be led to consider for the grade. So it means if 3 is the number of hours, so correspondingly grade is 3. So it means 0.5 change is coming into the Y, into the grade. So it means 0.5 coefficient value is added into the Y to calculate the grade. Again, let's say here, +1 change is there. So 4 number of hours the student is studying. So here, the change which is coming here, this 0.5 is the coefficient value will be changed here. So it means if 4 number of hours the student is providing for the study, so corresponding grade will be 3.5. So every time this coefficient value will be added into the Y. Every time this coefficient value will be added into the Y whenever +1 change is coming. Whenever +1 change is coming here, so this coefficient value will be added into the Y. So if the coefficient values are positive, they will be added into the Y. If the coefficient calculated values are negative, they will be deducting from the Y. So here, this is the coefficient calculated value, and these are the slopes. These are the slopes which are changing here now. These slopes are changing here now. So these are the different slopes are there. So basically, in straight line equation here, one is intercept from where the straight line equation has been calculated, and this intercept is negligible. And here, which is a value, this is a negligible value, which is a intercept, this one, and these are the slope here. We are calling it a slope or coefficient value here. So here, these are the slope here, and the coefficient values. This is the coefficient value, this is the coefficient value, this is the coefficient value. These are changing actually, okay? Okay, so these are changing value here. Okay. So in this way, your data are calculated here. Chandan, please wait, please wait. Wait, you need to wait actually. You're not plotting anything here. Just you need to wait. Wait, you're not drawing anything here. Just you need to wait actually, please. Okay. So the point is here I'm making a conceptual understanding that how uh, this slope, whenever change is coming into the x values, whenever change is coming into the x, these are changing by +1 or +1 every time. So these are x. So if whenever x values are changing with +1, so correspondingly change is coming into the slope. These are the slopes. So here these values will be added into the y. So this is y. So these values will be added into the y here. Okay. So means every time you should remember whenever changes are coming. So it means whenever input value is changing by 1, so corresponding coefficient value will be added into the y to make the new value of y here. Okay, so this is one, just wait here. So let me take out that how these coefficient values are calculated now. Okay. I can understand here, student, like topic is like quite complex, but you need to take it actually because you need to understand this topic here. Okay, though the things are complex here. Okay, so here let's say, suppose regression. Let's understand what is the regression here. Uh, okay, just wait. Regression is basically, it is used to identify the relationship among the variables. Variables means column. Use these relationships to make predictions. It means we are having a data and by understanding what is this data is speaking, is there any relationship between the data? So we need to make the predictions here. Regression. So regression analysis is a set of statistical process for estimating the relationship among the variables. Regression analysis describes the relationship between two or more variables. It includes many techniques for modeling and analyzing several variables. Then the focus is on the relationship between the dependent variable and independent variable. So basically we are having dependent variable and the independent variable, and there's a relationship between the dependent variable and the independent variable. Now suppose here, wait just a moment before taking further. Suppose here I'm taking, let's consider I'm having serial number educational qualification of a person, and I'm having experience. Okay. And here I'm having a salary. A simple things here I'm taking. Means here I'm having educational qualification, experience, and salary. So what I'll do, I can consider this one as the X1, this one as the X2, and salary as the Y. So Y is, suppose I want to predict its salary. So salaries are based on educational qualification and experience of the person. Okay. So this was the salary here. Okay. Fine. So means salary is based on educational qualification and experience of a person. Got the point? So Y is a dependent variable. You can call it a label. You can call it a target. The salary is to predict, salary is a dependent variable, which is dependent on education, qualification, and experience. You can call it a output also. And here X1 and X2, I can consider it as the input data. Now, if I'm taking that one into the equation, so how can I write the equation? I can write here Y is equal to A plus B1 X1 plus B2 X2 plus error. E plus E. So basically now I'm taking how many variable? Two variable. So X1 is educational qualification, X2 is experience, and this Y is salary. So it means salary, which is a dependent variable, is depending on intercept plus coefficient of X1 plus coefficient of X2. And X1 and X2 are what? Education, qualification, and experience. So whenever I'm having multiple inputs also, multiple variables also, so my equation goes in this way. And these coefficient values are being added to predict the salary whenever +1 is increased in the input of these independent variables. Okay. So I'm taking it this one. Regression analysis is the set of statistical process for estimating the relationship among variables. Regression analysis describes the relationship between two or more variables. It includes many techniques for modeling and analyzing several variables when the focus is on the relationship between dependent variable and independent variable. So it means there is a relationship between the variables. Regression analysis helps one understand how the typical value Yeah, there's all nodes up inside the nodes and resources repository. We are loaded it. Regression analysis helps one understand how the typical values of the dependent variable changes when any of the independent variable is varied. Regression analysis is widely used for prediction and forecasting. Okay, regression analysis is widely used for prediction and forecasting. Regression analysis is also used to understand which among the independent variable are related to the dependent variable and to explore the relationships. So the point is here, we are having types of regression models, such as one explanatory variable I'm having, it means one input variable I'm having, or two or two plus input variables I'm having. Both, if I'm having any of them, we can use the regression models. How the regression equation works. This one is a regression equation here. Y is equal to A plus BX. A is the intercept. B is the coefficient value, the slope value. X is independent variable. E is error. And Y is dependent variable. So all the details are written here. So we can call this errors as the regression residual error. Regression residual error. This also we can call it. Okay, certain time. Wait here. Okay. Like this equation right now, I discussed you with the salary, if that education, qualification, and experience are basically main input variables. Okay, so these are in this way the equation could be settled, where A is the intercept, B1 is the coefficient of input variable x1, B2 is the coefficient value of input variable x2, and goes on. Okay, where do we use the linear regression? The linear regression is being used for detecting the income and educational level, demand for electricity and the weather, and home sales and interest rate, and many more. Suppose I want to predict a car price, so I can use that. You should know, like there are many companies who take the car and predict the car prices. They even ask you whether you want to sell out your car. There are certain companies are there. There's one of the major company. I forget the name for that company. Cars24, I feel it's so. They use all the data science and machine learning. Cars24, you had heard about. And there are certain more other companies are there. So they just take the old car and they predict the price and then resell it. So it happens, right? So they just use all these data science and machine learning to predict the prices. So income and education level, demand for electricity, home sales. So here entire regressions are going on. This was a linear regression. Here, linear regression suggests you like this one is a straight line equation here. And the point from where the maximum data points are covered, that one is the intercept. This one is the intercept basically. And this is the slope. This is the slope, and this one is the calculated coefficient value, which is coming into the change in y. So whatever change is coming in y, that would be added here into the y. Okay, so this one is a straight line equation. Y is equal to mx plus b. It is not, it is y is equal to a plus bx. You can take it anyway. B is, it is considered it as the intercept. So that is a here, does not matter. M is basically nothing, slope, coefficient value. Some variable names are changes here. That is going. Here, just to read. Okay, here it is just given here that suppose this is the regression line here. Just wait here. Okay, let's say suppose this one is a regression line here. Oh, wait here. Suppose this one is a regression line here going on. So how the error terms are calculated? Error terms are what? Like actual data. Wait. It is not. That one is, it is taking the machine answer and actual answers. Just add all the machine answers and the actual answers. Find their squares and divide it by n. That is your residual errors. We call it errors. So these gaps are, these are the gaps here. These are the gaps here. It is just showing that suppose your actual answers are here and the machine is predicting answers here. Your actual answers are here and machine is predicting somewhere answers here. So these gaps, these are the gaps. These are the same gaps here. Suppose machine is giving answer for 2 plus 2, 8, but actual answer is 4. So this is the gap here. 8 minus 4 is the 4 gap. So these are the same gaps. So basically one needs to consider the gaps, that how much is the gap coming between the actual answers and the machine predicted answers. Okay. So here linear regression model is going to be considering this equation. This is the same equation here, but certain time here you can find out in this document that just wait here. You can find out here, like here I'm writing this one. No, this one is nothing. This one is a y is equal to a plus b1 x1 b2 x2 goes on plus e. So this one, they are denoting it with A, they are denoting it with B0. Intercept, they are denoting it with B0 here. And this B1 is denoted by B1 is as this, and B2 is as this. So it means A is denoted by B0. Does not matter, it is same intercept. Any of the way you can take it. It shows that if I'm having data, I'm having a lot of data set. So those data sets are having a relationship. Those data sets are having the relationships here. Yeah, M will be changing. Yeah, M will give the change in Y whenever X is changed by unit 1. Okay, so if I'm having a data set, and this data set, when I'm having a data set, and this data set shows that there is a relationship. This data set shows the relationships. Okay, that data set has the relationship. We need to find it out. Estimating parameter least square method, this one is just to find out the errors. Least square method is to find out the least errors. So here, suppose I'm having a data. So these are the data points. So straight line equation will try out several lines to make the straight line. Like here, this red line is making only 2 points. So this is not a right line. So intercept is not working well. This point is not working well because only 2 points are touched. It will try out for certain more points. Suppose here, it has just come a little bit down, gray line. The slope has been changed because here intercept is trying to make a line where maximum number of the data points could be settled. So here now, how it could be settled well when the values will be going in this way. See here. This new line which I had drawn now, or let me change out the color, it was much better. Let me take out this and highlight it this way. So suppose here I'm taking in this way, see, in this way. So this line which I had drawn now, this thick line, this is a straight line equation. And you can see the point here. Which one? This one, this point here, this point. So this is the intercept. This is the intercept from where the best fit line is coming here. Y is equal to A plus Bx. The best fit line it is making here with 4 points. Okay, so it means here the machine is trying to make the maximum data points fit onto the particular line. Least square means one needs the best fit. Best fit means this line should be onto the best fit where maximum data points are lying on the line. And if the line which is making, that one is making the best fit. So the actual answers and the predicted answers are nearby. There is no error. There is a least error. This I'm showing here. These are showing the errors, that how the errors are fixed or considered here. Just like here, it is considering the error that if the answers are coming different, actual answers are lying here and machine is giving answers here. So there's a difference between the actual answers and the predicted answers here. So it means here we can find out the least square error. Least square error means here just find out that how much is the error machine is giving, how much is the difference coming with the actual answers and the machine driven answers. These are the same one here. These are the same least square error I'm showing you, that the error should be less. Okay. Now, okay, let me take out this way here. Here you'll be understanding more. Just wait here. Okay. You can see here. This one is a case study here. which is related to the child birth weight and the mother estrol level, where the regression is used. Entire equation of the regression is used here. Uh, See here now. Just consider, suppose I'm having a data set. Inside this data set, you just consider I'm having two variables. One is mother estrol level and another one is a birth weight. Okay. Mother estrol level and child birth weight. So basically, as per the statement, here it is trying to find out that what is the relationship between mother estrol level and the birth weight. It means it is trying to find out, is there a relationship between the child birth weight and the mother estrol level. So some of the data has been provided here, some estrol level and some child birth weight data, gram per 1000, and here milligram 24, some H unit is given, some or like medical values are given. Okay. Now these two data are given. So one is to find it out whether some relationships are there between the mother estrol level and the child birth weight. Okay. So while looking this data, na, students, just to listen this, read this query carefully. What is the relationship between mother estrol level and child birth weight? Can you think it? You have to give me answer. You give me that which one is the dependent variable here? Which one is the dependent variable and which particular column is the independent variable? You think it. Give me mother estrol level or child birth weight. Which one is good? Good. Which one is the independent and which one is the dependent variable? You have to tell me. I need your answers. Exactly. Correct. Right answers, those who are given. So you're saying child birth weight is, this birth weight is dependent variable and this estrol level is independent variable. It means child birth weight is totally dependent onto the mother estrol level. Exactly. Birth weight is dependent, mother estrol level is independent. Exactly. Correct answers. Thank you for your response. Okay, fine. So one of the things we had detected that birth weight is independent variable and estrol level is dependent variable. So here I can give it independent as a X, child birth weight as the X, which could be dependent, which could be label, which could be target or output. Any of the things you can just say. Now come here. We are trying to make a plot of this data. So here, if we are making a scatter plot of this data, scatter plot of this data, you can see here the data points are points are coming here. This shows that there is a quite relationship between the mother estrol level and child birth weight because the data are going towards the positive side. If mother estrol level is increased, so the child birth weight is also increased here. Okay. Fine. Okay, so here it shows that mother estrol level is increased and correspondingly child birth rate is increased. So it shows that, yeah, there is a relationship in this data. There's some relationship into the mother estrol level and the child birth rate when we are plotting the scatter plot. Now what I do, first of all, I need to make certain calculations. So for this, I need the data. So this X and Y, which is coming here now, they are what? They are the values of estriol level, mother estriol level, and this is a birth weight. So one is calculating the X square, one is calculating the Y square and X into Y. And here, sum of X square, sum of Y square, and sum of X into Y, sum of X and sum of Y. So all these values we are requiring actually. X, sum of X, sum of Y, sum of X square, sum of Y square, and XY. We need it. Okay, so we did it. Now let's go. Come here, parameter estimation solution. Now here, first of all, see, just wait. First of all, I need, see, if I want to settle down the value here, y is equal to a plus bx plus e. This, or you can take it as y is equal to b naught plus b1 x plus e. Any of the thing does not matter. So here, we need to calculate this b1. Let me take out this b1. b1 is the coefficient value, or here you can take it coefficient value. b1 is what? This is the coefficient value. We need to calculate it. So this is the equation. You can see this long, big equation. Sum of xy minus sum of x, sum of y divided by n, whole divided by sum of x square minus sum of x square independently and divided by n. The point is that this is the entire equation to calculate the b1, the coefficient value. So the above in the data set from the table, I'm taking all those values which above I had shown to you. So 37, which is the sum of x into y, then 15 is coming from sum of x, 10 is coming from sum of y. Okay, divided by total number of n are 5, total number of rows are 5. X square 55, sum of x is 15, making the square of it and divided by 5. The point is that these all values are coming from above data set calculation right now I had shown to you. So when this is calculated, 0.70 is the calculated coefficient value. This B1 is a 0.70. You can keep this 0.70 here. So here it is saying coefficient value is 0.70, or here also the same thing I'm telling you. Both are same. Both equations are same. So coefficient value is 0.70 here or here. You can take it as a B1 or B, anything. Okay. Now we need to check it out here. Just wait. Now see here. Now we need to wait here. Let me do. Wait. Okay. Now I need to calculate the value of B naught. Means this B naught I need to calculate. B naught is what? A means intercept. One needs to calculate this B naught. Okay, so how one is calculating the B naught first? So B naught is equal to y minus B1 x. So B1 values right now calculated 0.70. This one is a B naught 0.70. Now I can take any of the value of x and any of the value of y from the above table. So here, just like here, it is taking see here. Wait. Let me take out this value. Wait. See here. Child birth weight is 2 when mother estrol level is 3. So mother estrol level is x. So mother estrol level is 3 and child birth weight, which is y, is 2. So 2 minus 0.70 into 3. So here I just put it, the values, same values here. You can see the below here. this. So once it is calculated, so B naught one is going to find out. So B naught is equal to B naught means simply you can take it as the intercept, this intercept, or you can calculate it as a. So it is minus 0.10. So B naught value is minus 0.10. So here you can keep it. Y is equal to minus 0.10 plus 0.70 as the coefficient value into x plus e. So x and y are what? X and y are estriol level, and y is birth weight, child birth weight. So this is A intercept. Okay, what does it mean? It says this value. This is this value. This is A. So this value, this one is 0.10 means minus 0. Minus 0 means nothing. What does it mean? Here it means, see, when this A is going to work, this A is going to work when we say that, okay, just wait. First, let me give some values. Suppose here I say, I'm taking some values from here. Okay, here, suppose mother estriol level is 3 and child birth weight is 2. Mother estriol level is 3 and the child birth weight is 2, let's say. So now I can consider, suppose mother estriol level is increased by 1. Mother estriol level is increased by 1. So what is the next value? 4. So this coefficient value will be added inside y. 2 plus 0.70. Whenever plus 1 is changed, so the required coefficient value will be added into the y to predict the birth weight. So what is the birth weight now? With 4 mother estriol level, the child birth weight will be 2.7. Now again, plus 1 is increased. So 5 is the mother estriol level. So correspondingly, inside this 0.7 value, which is coming from coefficient, that would be added. So here 3.14 will be the child birth weight. Mother estriol level will be 5. So correspondingly 3.14 will be the child birth weight. So whenever plus 1 is changing, we are not taking on our own any of the values as 2. These values are coming from the table here. The value of the 2 or the value of the 3 is coming from the table. Okay, we are not taking any values here. All this, by basis on this data, this table is generated, and with the values of this table, B1 is calculated, and once the calculation is done, B naught intercept is calculated, and these values we are using it here. So all the values we are checking it out from here, the table. Okay. So these are the table generations are there. Now here, suppose, just wait here. So here, remember that whenever plus 1 is increased into the x, so correspondingly, coefficient values will be added into the y. Again, plus 1 is added. So again, 0.7, 3.14 plus 0.7. The coefficient value will be added into the y to predict the child birth weight or to predict the dependent variable value. So whenever independent variable value is increased by 1, so corresponding y value will be changed after adding the coefficient value. So if the coefficient is coming as a positive, here the coefficient is coming as the positive. So the positive coefficient value will be added into the y to predict the next value of the y variable, dependent variable. And in case if our coefficient values are negative, suppose, so coefficient, that negative value will be deducted from the y variable. It means it is making the difference or the negating the value of y. So where y value will be coming down, then negative coefficients are there. Now suppose here, consider if I am taking this case right now, y is equal to a plus bx plus e. Right now I'm saying that whenever +1 is done, so coefficient value will be added into the y every time whenever +1 is happening. But consider a situation where my x values are 0. So right now, if I check here, if I'm checking out here, what is my b naught? What is my b naught value intercept? This is minus 0.10. So I'm saying if my x is 0, let's consider my input variable value is 0. So this entire term will become big 0. So what is left? A. A is minus 0.10. So A will be given to Y. So what does it mean? It means if mother estriol level is 0, so child formation is not possible. So this A value, intercept value will be given to the child birth weight. So nothing birth weight is there, no birth weight is there, nothing will be there. Because it is 0, minus 0, nothing. So it means this is the interpretation. So basically here, whenever +1 is adding, whenever unit 1 change is coming into the input variable, so corresponding coefficient value will be added into the y to give the next value of the dependent variable. Whenever this entire x is 0, so this particular term will be 0. So the remaining intercept value will be given to the y. And generally, this A is almost nearby 0 only, minus 0.1, minus 0.2, from where the straight line equation is making the best fit line. So in this way, we need to understand this. So the point is here, basically, like, wait here, just wait here, wait. Okay. So here, we can understand like, see, basically, you are not going to make the calculation, though it is very complex. But here you are not going to make any of the calculations. For this, we are having a library, Scikit-learn. Scikit-learn. You can Google it now. You can Google it now. Scikit-learn is the library. Okay. You can just Google it, Scikit-learn. Scikit-learn is the library, which is a machine learning library. And inside this machine learning, you can do entire machine learning with the help of this library. Inside this library, we are having a linear model. And from there, we can drag out the linear regression class. Inside the linear regression class, we are having all the methods which we can use for the linear regression work. So nothing, these equations, you are making the calculation. Don't worry that, ma'am, so much calculation you have to do. You are not going to do nothing, actually. These are the underlying concept of the machine learning. I'm telling you that how the maths is working behind it. But actually here, expression you should know that y is equal to a plus bx. These are the basic general linear regression equations are working. Yeah, but you are not going to make the calculations like here I'm showing you the calculation, this calculation you're making. This is not your work. For this, we are having a library. A lot of libraries I'm having. Scikit-learn library, we are going to use it for the machine learning. There is a lot of packages, lot of modules, lot of classes are there. Like you had learned about the class, how to make. So that is pre-prepared. I'll just call them and use them. I'll just send a data set to it, use the scikit-learn kit and start working with that one. So that is basically working behind the machine learning here. Okay, got it now? Though the topic is, it is complex, I can understand, but here you need to conceptualize the topic. Basically, you need to understand how the things are working. So next time I'm going to take direct libraries, scikit-learn, I'm going to use it. I'll import scikit-learn, and then scikit-learn is already present in your Anaconda. Once, because you installed Anaconda, scikit-learn is there. Okay, have you Googled scikit-learn? Okay, that is there. So next time I'm going to take the libraries here. I'm going to take everything step by step. Okay, Sandra, fine. Step by step approach I'll be using. So we'll be using a scikit-learn kit. Directly we'll be importing, taking the data set and working on it. Okay, so that's all for today. Thank you. Thank you very much.